So Samsung dryer. This is a double heater one. Let's go with this. This is a DV42, and then there's others. Anyways, DV42. With the Samsung dryer, there's a little poor secret. The heat relay, which is over here, that's a double one. This is a single one. Let's look at the single one. Wow, I got this from the tech sheet. So this one's labeled single. You look at the heater, there's two heaters. This one's labeled double. There's only one, so the tech sheet is wrong. Anyways, heat relay right here. So how the heck does that work? I don't know. So you have the heat relay. Oh, L1 goes to the heat relay right in there through the heater, that heat relay. So Samsung has a weird thing where they will not close this heat relay, which continue on this side through the motor, centrifugal switch. Remember, the motor turns on, goes click, and it closes that part of the circuit when the motor is running. It goes over here to line 2. So to turn that heater on, you need centrifugal. You need one. First of all, you need line 1 to line 2, 240 volts potential between the two. You need this relay to close. You need your high limit and your safety thermostat to be good. Your heater and this motor centrifugal switch to work. To close this switch right there, the motor needs to run. Well, duh, you got this one here. No. Let's take a look at this. So you have neutral. This is neutral. This is your door switch. Door closes. Notice there's no light. Or wait, the light's over here. So this is neutral. Right here. So you close the door. Neutral is right here at the motor. So you have line 1. Line 1, which is this one over here. I'm just gonna keep line 1 goes to your computer board here. This is your motor relay. You press start, motor relay closes, click, it starts. You have your belt switch, goes through your belt switch first, has to have the belt on. The other thing, this is your thermal cutoff. This one's the one on the blower housing. Then you have your motor. Then, of course, you have your little safety limiter on the motor itself if it overamps. So, when this motor starts, when this relay, the motor starts to rotate, and then the centrifugal switch goes click. You'll notice here, this is neutral, right? Because it's past the load. This connector here will actually come down and click. So what that does, so now you have neutral coming up here. That means your water steam valves will not work unless the motor's running, electrically wise. So this is all neutral. And this, you notice this line right here. Wait a second, that's neutral. Back to the computer board. Where does it go? This. The only purpose of that neutral back to the board is a signal. So the whole board knows that that motor is running. Nothing else. It's in the algorithm, the little fuzzy neurons, if you will, or fuzzy logic, as I think it's LG or maybe it's Samsung. LG. Anyways, fuzzy logic of the computer board needs this neutral right there at black 3P pin 3. It's number 7 also. There's brown, blue, and black. 3 pins on that computer board. So you could literally take your amp probe, your meter. I know most of you don't own a damn meter, but you should. Put it right there, neutral. Put line 2. You will have 0 volts until you hit start. Click. click. Oh, now you have 120 volts. If the motor's running and you don't read 120 volts from here to here, potential difference, or from here to here, potential difference, doesn't really matter if you're line 1 or line 2. If you do not read 120 volts, that specific part of the motor is bad. And that's why the heat algorithm will not run. And you will not get heat. Heater. You can replace all the parts you want in part and it still won't heat. What a lot of people end up doing, they take a jumper wire and jump this heat relay, and then it works. Of course it works. Because there's nothing wrong with the heat circuit. It's actually the low voltage logic portion algorithm of the computer board.